Okay, so as I said before, there are three basic types of nebulae. The one that we saw in the first lecture, and it is, as you can see, bluish in color, and these nebulae are called reflection nebula. Now the question is, why is it blue? What gives it the blue color? Its color is blue for the same reason that our sky here on Earth appears blue on a clear and a sunny day. Okay, it turns out, remember I said that these clouds consist of gas, which is about 75%, 3/4 hydrogen, and the rest, almost everything else, the remaining 25% is helium, and dust, small solid particles, which are usually compounds of carbon with silicon and oxygen. Okay? So, and it turns out that these dust particles scatter blue light more efficiently than the longer wavelengths, than say the red light. That's just the way the electromagnetic radiation interacts with matter. It turns out that shorter wavelengths are scattered more than the longer wavelengths that can actually work their way around the solid particle, right? The shorter wavelengths are comparable in size to the particle, and therefore they get scattered. The longer wavelengths can just work their way around the dust particle. If I have a glass prism and I pass through it sunlight that kind of appears to us to be white, so here is sunlight, then as those of you who took astronomy 1P01 will recall, different wavelengths propagate with different speed through the medium, which results in the fact that different colors get bent by a different amount. Will get bent by a certain amount, and the blue component turns out it gets bent much more. So using this prism, we can resolve the sunlight into different components, different colors in so-called spectrum. Let's look at the reason why the sky is blue. So if this is the sun, okay, and on the ground there is a person, okay, so here is the person on the surface of the Earth, right? So if I look at the beam of the sunlight, and of course there are many more beams coming in all possible directions, then as I said, the blue light gets scattered very efficiently in all possible directions, while the red light doesn't get scattered by the same amount. Okay? So what is happening, because the blue light is scattered by the dust particles in the atmosphere in all possible directions, to us on Earth it looks that the blue color light is coming from all possible directions. And that gives the sky this blue color that we observe. For the same reason, the sunsets and sunrises are often red. Okay, so here is again our observer on the surface of the Earth, and this is the direction to the setting sun. Okay, so then what happens is that basically in the sunlight coming from the setting sun, the blue light is all scattered out by the time it reaches our eye. However, the red light makes it through. Okay? And also the same, to some extent, happens with the yellow light, which has a bit longer wavelength than red light, and definitely, shorter than the red light, and definitely longer than the blue light. Okay? So what we have here is the blue light is carried out, and now it's of course traveling a longer distance, because when the sun is above us, the thickness of the atmosphere, the layer of air that the light has to travel through, is much smaller than the distance the sunlight travels through the atmosphere at the sunset. I'll explain that in a second. Okay? So the sky is blue for an observer beyond the horizon, right, for whom the sun is directly above. But for this observer, for whom the sun is setting, all the blue light is carried out, and only the longer wavelengths, red and yellow, reach the eye, and hence the sunsets appear as red. Let me just explain the difference. So this is the Earth. It looks like egg here, but that's the best I could do. And I'm not drawing things to the scale. So this is the Earth, and this is the layer. I have exaggerated its thickness so that I can draw anything here. This is the atmosphere. So say this is our observer. So when the sun is directly overhead, so when the sun is high in the sky, the sunlight has to travel only this much distance through the atmosphere, okay? But at the sunset, the sun is, when it's setting for this observer, it's located here. And now you see that the sunlight has to travel a longer distance through the atmosphere, right? So all the blue light is carried out by the time it reaches the observer. And when it is high up in the sky during the day, the distance it has to travel through the atmosphere is reduced. Okay, so, and then the same scattering of blue light gives us appearance that the sky is blue, because the blue rays are coming from all possible directions.